Hello, my name is Jamie Lakshi, and this recording serves to recap the state of Group 9's compiler project that was given as a part of 2025's compiler course at U Antwerpen. This time I will recap projects 1 through 6. So in our compiler, we have implemented all mandatory and all optional features of all project 1, 2, 3, 4, 5, and 6, except for function pointers. Function pointers and their semantic analysis is not supported. This is also visible in the README. As you can see in the summary, only function pointers have not been implemented. And all the other features that we have implemented are below this. We've also implemented some extra features. As discussed previously, the inclusion of stdbool.h gives you access to true Boolean types, which are 1-bit integers. And it means that you can declare variables as bool or use true and false as the 1-bit and 0-bit constants. If stdbool is not included, then these are not keywords. So you could do typedef int bool, for example, which is one of the tests in the test sets. We've also implemented the size of type operator. It simply returns the size of the given type in bytes, given the current target data layout. We've also implemented the general malloc and free functions. These can be used to dynamically allocate any amount of memory for any type at any point in the program, which takes care of the 3 dynamic allocation features, which were dynamic arrays, structs, and character buffers. And then we have also implemented the implicit return of 0 in the main function if no return statement is present, which is small, but it does correspond to the C compiler's behavior. So now I will compile the tests. We have 242 tests in our project. And we have 5 different test sets, 0, 1, 2, 3, and 4. Now, test sets 1 and 2 are just those from Blackboard. 0, 3, and 4 are ones we created ourselves for our compiler. As you can see, all the tests are passing, and test set 2 and test set 1 are wholly here. And so the test displays a pass, whether or not it was compiled and whether it was expected to fail or not, perhaps due to a semantic error or something, or syntax error or something. So yeah, that's all test set 1 and 2, and all the additional tests that we have. Now I will show another file. I will start compiling it and then I will show. So we have assigning const pointer to non-const pointer discards the qualifiers and possibly losing information due to casts on line 26 and 36. So I just compiled this file. It shows project 5's overloading of functions and the amount of types and parameters. It shows project 2's const casting, as well as the modified constant propagation, which we should see in int A. Then we have project 3, which is the dynamic array, which, as you can see here, this clearly implements an array of 5 ints, freezes it again. Then project 4 is also here. We have the if, else, if, and else block here, which is project 4. Project 4. And then for project 5, prevent headers from being included by implementing include guards. I will show later. Check for all paths in function body is also shown later. And the optimization do not generate code for unused variables. We have an unused variable here. We should see it be removed. And then we also do not generate code for conditions that are always false. Is this here. We should expect to just see the scope of A equals C. Yeah, so I will now go look at, or I will now pull up the folded AST. The details of how to use the compiler are also clearly written in the README file. So let's have a look. First, we'll look at the folded, the graph. Oh. So let's look at the folded graph. We have here the 3 functions with their different signatures that are defined. Yeah. Then we have the first scope where we had the const cast pointer, which clearly, as we saw, it did give a warning. The assigning const pointer to non-const discards qualifier. And as we see later here, integer a equals x. This was not constant propagated, even though x is const and defined, because that's because it's a const cast. And then we should also have a look at yeah, the dynamic, I will show it in the LLVM soon. The statement if else if is also been changed. So clearly you go to if, and then if, then the else is just an if and an else, and this else is the original else, and this if is the else if. So this is also correct. Then we should see the statement int equals g, but you can see that it has no declaration attached, like here, for example, which means that it was called by the optimizer. So that's also present. And then we have this statement if 0 ab else a equals c. As I said, we should just see the assignment of a to c because 0 is known at compile time. So we have our assignment of a to c directly here. And then you also have the different call versions. So I'll show this in the LLVM now. So let's see this program. So let's look here. You clearly have, okay, you have malloc and free defined, and you have the integer add integer integer, the floats add float float, and the float add float float float. Yeah, so those are clearly in the program, but I will show also where they are used. But first you have this call to malloc to assign 20 bytes clearly here for the array, and then it's freed again later. And now I will look for the calls to the functions. You can see them here. So as you can see, the first one was integer add integer integer, the second one was float add float float, and the third one was float add float float float, which is what we see here. So those features are all covered now. Now I will show another demonstration. Now I will show first the symbol table as well. As you can see, there's a lot of information. In the global scope, you have declared functions and defined functions, which are the 3 functions we expected. Then we have the 3 function scopes that are attached to that. Then we have the main scope, which has a bunch of variables and unused variables. This was the wrong file, I believe. The unused variables g, which was what we saw. Then we also have here, this scope is where non-const pointer was defined, and we also keep here, we use a symbol table to keep track of which pointers point to what, and what their aliases are, and who they point to, and so on. So that's how we did that, and the rest of the table is pretty standard, nothing happens. Okay, so that's an example of the symbol table too. And now we'll compile, now we'll give 2 more examples quickly. So you have this file, which is this file, where we have the union, for example, the enum as well, structs, defined in another struct, and a union too. Then we have just the print function. We have the dynamic creation of a struct. And we also have the dynamic creation of car buffer, both using malloc. You also hear the size of operator is used. And then we have fgets and fputs as well, also using these character buffers that were dynamically allocated. And then we have a free at the end to clear them again. So if we look at the program, and I will close the other one, if we look at the program here, it's clear that like these structs, for example, have been defined as like a struct foo is one with just an i32, and then a float or int struct is a one that contains i32 and a struct and a union that was also user defined. Then we have fgets and fputs. Yeah, then we have a printf and fgets and fputs also being called in this main function here. So we have malloc for the character buffer. We also have malloc somewhere for the string here, for the struct I mean, which is this very clearly. And then we have a call to file read, which is what is fgets, and file write will be below here. Okay, so that's those two optionals as well. And now for our final compilation is to show off the header guards. This here. So what did we just compile? We compiled demo pin-c, which has includes two vehicle pins A and vehicle pin C. Now here is now here below first is an array of structs, and then if I look further here, we have the inclusion of vehicle.h in vehicle.c itself. So if we didn't have header guards here, it would have been included twice, and you know, the definitions would have been declarations would have been there multiple times, or no, the definitions of structs would be there multiple times, so the compilation would fail. And then we have again a struct and an enum in a struct, and so on. Yeah, and that's all the features. Yeah, that's all the features that we have. So goodbye.